Welcome to the Reimagine Mobility podcast series. I'm here with Brian McCaskey from AVL Simulation Organization. Thanks for joining me, Brian. Let's talk a little bit about simulation that for one moment. Let's talk not necessarily traditional automotive space that in the past I had guests on that really focused on that. But let's talk a little bit about other industries that you, as part of AVL and certainly also other companies in the simulation space, provide services to, provide simulation tools and products to. So highlight a little bit those areas, and then also why can they use maybe a product that also a simulation engineer uses for passenger vehicles, for example.
Sure. Well, thanks, Stephan, for having me on the podcast. Indeed, so the simulation suite that I support is the Multi-Body Dynamics software Excite. And with that package, it allows you to really do a lot on the mechanical side. And so if you think about areas such as, let's say, wind power, a wind generator basically is a number of different, let's say, gear sets within a transmission that are connected to a big propeller. You have mechanical parts in there, you've got gearing, you've got bearings. So in that case, the software that we offer that many customers use for the passenger car segment also work for this as well, just on a much larger scale. So for example, if you're interested in bearing wear or bearing loads and seeing if you've got a nice even profile during your calculation, you can do that on a large scale with our EHD, the elasto hydrodynamic calculation. And it's very accurate, it's very powerful, and it really gives our customers a good idea of what's happening with such a situation, because we're talking about tens of thousands of pounds of load that are being introduced into that gearbox and into the bearings themselves. So that's one area that we've had success with a particular customer here in the States. Really, they reached out to us based on some marketing material that I had recorded 3-4 years ago, and said, "Hey, I think that this looks like something we can use for our design work," and they have very successfully. So that was very exciting to have something like that happen. Additionally, we've got customers that are doing rotary engines, so you can use the software for rotary engines as well. Again, the same sort of concept. You're looking at gears, you're looking at bearings, all things that are within the passenger car space, but still applicable to to developing wear, developing high loads, and trying to figure out really what is going on with that system, or even non-conventional powertrains. Maybe opposed pistons, or there's so many different applications that our multi-body tool really allows you to simulate with.
So as a not simulation expert or simulation tool expert, when I listen to this, I almost feel like wanting to say, and I know it's wrong, but I would like you to explain why it is wrong, not necessarily me. I just know it feels wrong, but I can't really explain it. When I listen and say a wind turbine, I use simulation for a wind turbine, and I use simulation for a internal combustion engine, okay? I'm like, isn't a wind turbine so much more simpler than an internal combustion engine? So isn't that simulation tool almost an overkill? But again, I think my engineering background says I'm way off here, but I can't explain where I'm way off.
Sure.
Am I way off? And if yes, which I assume so, can you elaborate a little bit on it, where I'm way off?
No, I think your assumption is right, Stephan. It is definitely a much simpler system, but if you think about it, you've got some input loads and you've got some output loads that you're looking at, and that's all going to stay the same regardless of whether you have a turbine connected to a single gear pair, or if you've got an engine that's connected to several pistons and several bearings together. You still have that input and that output section that you're trying to evaluate. So even though it seems simplistic, the concept behind it is pretty much the same. Again, we're just dealing with things on a different scale level. You still have the input loads that you're looking for, impacts that come from the wind turbine that might be affecting the bearings and the gear different than you would have in a traditional internal combustion engine, for example.
Okay, so I wasn't too off, but at the same time, still not totally right here.
And that's
Maybe a
and that's the
different.
nice thing about that's the nice thing about our multi-body tool, Stephan, is that you can start things out in a very simple conceptual stage, and you can slowly build that up in complexity based on when your design parameters are becoming more and more clear as your engineering teams are providing you more and more data that gets you closer and closer to that prototype that you're going to run in a test cell or go on the road with or in the field with. So it really allows you to kind of use building blocks to increase that complexity as well. So that again, the simplicity is not really an issue. It's just the fact that you want to try to get as accurate as you can with as much speed as you can.
Maybe elaborating what you just mentioned from a complexity, you can start out something using the tool for very simple, or I call it basic things, maybe less complex, and then go all the way to the most complex, really pushing the tool's capability, right? Where are most of the customers that you're dealing with, where do they fall? Very basic, just quickly want to do something, kind of like a cursory check. Yeah, it looks like what the guys told me is good. We can go produce this part. Or is it no, they take the tool because they really want to go into the nitty gritty? Can you shed a little bit of light on that?
Sure. As engineers, we don't want to take the shortcut. We don't want to take the easy way. We want to take the hard way. So 9 times out of 10, 99 out of 100, the customers are going for the most complex model possible because that's what the end goal is for them. One of the things we always try to stress in the training courses and even in our support day-to-day explanations is if you have something you want to get to a very complex bearing analysis, a very complex gear geometry, start out with something that you know and understand the dynamics of first. So for example, within the software, we have the possibility to specify a simple nonlinear approach, which is just basically a spring damper approach for a bearing, as opposed to the full elasto hydrodynamic, which is including the Reynolds equation with mass conservation. So instead of going to that full EHD bearing, for example, start out with your nonlinear bearing, make sure you understand the dynamics of the system, that the loads are looking right, that the behavior of the various bodies and components you have is correct, and then slowly ramp up just to make sure that you as an engineer don't have to backtrack all that way once you're 3-4 weeks into a project and say, well, gosh, something's wrong here, what is it? And then you've got to go all the way back to a simpler simulation and then work your way back up again. So it'll save you a lot of time if you do that in more of a very intentional way when you're building up a simulation model.
Okay. Where do you see simulation tools go in the future? I'm sure if we were to look back, which I not necessarily want to look back, I want to look forward. If you look back, I'm sure there was at some point, maybe you call it an inflection point, where people did not just use it to double check what they did through other methods, their design, but really started shifting over and saying, simulation is now my main driver of the design. And I use my old main ways to now double check maybe the model. Again, I don't know how long ago that was, but forget that for a moment. Where do you see simulation going forward if you now say, today 99% of the users really use it to go in highly complex and really into what I call the nitty-gritty details, which yes, us of engineers, that's what we need to do, that's our job, that's what we're asked to do. But what do you see simulation going forward? If we're already using it 99%, what's the next frontier for simulation?
Right. I think the shift has happened from and I know you don't want to go backwards, but I have to go backwards because when I first started in my engineering career, which was back in the mid-90s, I started out doing finite element analysis, doing stress analysis on engine blocks and transmission cases. And at that time, they always mocked up 5, 10, 15, 20 different engines, and then they said, well, let's go to the simulation to make sure that is what we're predicting. So simulation always used to be a kind of a backup to verifying what was happening in the testing. Over the course of that last 25 years, what I've seen is a shift, the balance from being simulation down here and testing up here to really, it's really evening out. There's this terminology that's used, the virtual twin, trying to come up with a simulation model that mimics exactly what you have in a test cell or out in the field. And what I really see in the future, especially with the advances in computing power, the advances in calculation speed, I really see that shifting to the point where engineers have enough confidence with the simulation side that they don't necessarily need to have the prototyping to really say, yeah, this is a good design, or this is a bad design. Simulation has gone from being kind of well, this is kind of cool, but it's just for, these engineering nerd guys, to being, well, this is really cool, and, the pictures are nice and the colors are nice, but it really is telling me what's going on in the simulation. And I can trust it because I've been, told this for the last, 5-10 years. This is right, and I've proven that. So I see us moving more from being really reliant upon that testing on a physical model to really focusing on the virtual side and really pushing the limits there to drive the designs and drive really the direction that we're going. And the other thing that's very interesting, being a mechanical engineer, we've had this big shift, this switch that's been turned going from IC to EV stuff. It's been hard for me in my mind to make that switch, partially because I'm a mechanical guy. I took one electrical engineering class, didn't like it. I still don't like it. I've done electric work in my house. I understand, when something breaks, I can fix it, but when it's electricity, it zaps me. I'm like, well, where did that come from? So I think the hard part for us as mechanical engineers, engineers in general, with the EV side, there are so many different phenomena that are happening that we can't predict and we don't understand as of yet because it's so new. I think of what, 100 years ago when the IC engine was just coming into its own and being developed and really becoming more accepted. How many things we've worked through and understanding the phenomena there. It's going to take us some years to come to that point, but I believe that simulation is going to help us get there a lot faster because we have the technology, because we have the computing power, because we've got that 100 and some plus years of IC engine experience. I mean, mechanical parts wear out, whether they're in an IC engine, whether they're in an EV, it doesn't matter. Mechanical parts are mechanical parts. So we still have that we can rely on to really push forward. So I really see us focusing more on the simulation as driving the designs and driving the prototyping as opposed to, having to mock something up in, again, in real physical terms.
Sure. Clearly, I agree with you. I think, if you look at the history of ICs and how long we've had to become smarter and smarter, better and better, more effective, more efficient, all the right buzzwords here. And I think sometimes maybe as an industry, we expect to be as far along on the EV side and maybe a less complex system, but it's also, again, as you mentioned, almost a brand new systems, right? Now we have batteries. Before we had gasoline in a tank. Now our tank is the battery. Compared with a gasoline tank, a battery is a whole heck of a lot more complex and challenging, right? Yeah. But maybe jumping on this a little bit and talking about how is now what you mentioned kind of on parity, right? The physical with the simulation. And I think it's probably only going to go more simulation as we move forward. And we have several customers that reiterate over and over again, they want to get to 100% simulation as it relates to testing. So no more physical testing of anything and everything in a vehicle, right? How do you look at this with, again, 20 plus years, 25 years of experience, Brian? Are you saying good luck? Are you saying, I'm not sure, but I trust that simulation gets better and better? Or are you saying, no, I'm not sure 100% is real, but certainly more than what we're doing today? Shed a little bit of light on that.
So I think part of that shift that's happened with the testing versus simulation, that friction that's there, part of that is let's say the old school engineers who that was what they trusted. That's what they used for 30, 40 years in the engineering field. With the engineering field that we have now, simulation is more accepted. It's taught in at university level. it's in every company that we work with. So I think that maybe this changeover effect of having a new generation of engineers is also going to try to drive that simulation reliance upward as well. And I think that's why it's going to. I think that's why it's really going to increase. I think we'll always have to have some prototyping. I think it's, simulation isn't going to solve and be able to predict everything. It's going to help us understand phenomena. It's going to help us get really close to that real design. But there's always going to be human factors, tolerancing. I mean, there are always going to be little things like that could cause problems that we may not necessarily be able to predict in a simulation setting. So I think even though we're at this even, like you said, the parity within simulation and testing, and eventually simulation is going to exceed that, I think there's always going to be some need for prototyping and testing, whether it be just in the field or whether it actually be in a test lab someplace. There's always going to have to be some aspect of that. But I think that simulation is going to be the driving force behind future developments. Again, just because this whole engineering generation we use computers for everything, phones.
Sure.
Everything's connected. It's a fascinating time. I think about my grandparents who were born in the early 1900s, and they saw the advent of the internal combustion engine, phones, computers, TVs. They saw all these things happening over the course of 100 years, and we're seeing a lot of stuff happening in 5, 10, 15, 20 years. That accelerated pace is pretty amazing of what we're seeing as far as technology goes.
Yeah. Maybe to add to that, if you go back into your 25 year career, Brian, and you look at all the things that you've seen and the surprises here that I expected this. What is something that you didn't think would happen and has happened, right? And I'm thinking the future might be, specifically when it relates to simulation, that we maybe have vehicles on the road that give us live data back from a battery, let's say, or still from an internal combustion engine, that then live feeds into a simulation tool. That simulation tool uses data that literally comes from a field, because you want to test for vehicles that maybe drive in Alaska versus in Florida in the middle of summer or something like this, right? I could imagine this with everything connected. But in your 25 years, and specifically dealing as a mechanical engineer and then getting into the simulation space, what is something that you said, I never thought that would happen?
Well, I never thought we'd be running complex simulations on a PC, that's for sure.
Okay.
I started out with those big old Unix machines, so I think that's maybe the most surprising thing is how complex and how compact computing power is these days. And I think, to your point, there probably will be something like that where we have live feedback that we get during a driving cycle in different locations, because we have that capability. Before you'd have to throw 3 or 4 PCs in the back of a car to be able to get that kind of data. Whereas now, I saw there was a commercial for a new truck on the road that's got a 13-inch touch screen on it. And I'm thinking, gosh, that's almost as big as my laptop screen. I can't imagine having that in my vehicle. What's next? So I think just the advances in computing power and the compactness, I think that's really something that's been surprising to me. Again, just based on my FE work and simulation work in the past. And we run into this all the time. We might want to edit this out. I don't know. We run into this all the time with the development cycle too, with the simulation software, because before it was like, well, we never thought we were going to need to have X number of gigabytes of space. So let's just say maybe 1 gigabyte of space. That was plenty 20 years ago. Well, sure. Now we're talking terabytes of space that we need for
small,
for some things. So I don't think anyone really could predict how large things would get and how fast they would get. I think, and that's maybe part of us as far as the human side. We look ahead and we think, okay, well, if we get here, we've arrived, and that's as far as we're going to go. But in reality, just like everything, you want to plan for, what is it? They say 20% more, 50% more, whatever the case may be. So it's definitely a challenge. It's definitely a challenge.
Wow. So last question, I'm going to put you on the spot a little because I know you've been as of late very much focused on simulation, but if we take simulation or the simulation space, really in my opinion, again, a key enabler for the future of mobility, and I think also a key reason why we're currently seeing so much transformation and disruption in the mobility space. But let's take simulation out. In your opinion, what do you see as another major disruptor and or industry transformation agent outside of simulation for the mobility space? Let's stay in the mobility space.
Well, I think one of the biggest things that I see currently is the infrastructure. I think that here in the Midwest, clearly if you, and I've done this before, you go outside when it's cold, you've got your phone out, you're making a call, you're checking something, the phone drains very, very fast because of the cold weather. That's a big hurdle that we have to overcome in an area like we have where the temperatures can be 90 degrees or they can be minus 20 degrees. How do you deal with a battery setup like that? I also live currently in a more rural area. If we had a plug-in for, let's say, 10 plugins for EVs here in my town, it would probably drain the power grid, frankly, because we have 800, 900 people in my town. So I think we really have to overcome, especially in the mobility space, we have to overcome some of these infrastructure issues that we have. I mean, we just had this big ice storm where, hundreds of thousands of people lost power. What happens in that situation if we're all EV? We'll be sitting in our houses waiting. And the trucks can't get out to fix the lines. There's a lot to think about as far as the electrification goes. I think that there's a lot of benefit to it. I think that is definitely where it's going because that's where everybody's pushing towards. But I think we really need to work on those limitations we have as far as getting power out to the EV. Is one thing that we're gonna have to really overcome.
Yeah.
And again, that's simulation aside. It's a huge factor, and we're seeing that. We're seeing the ranges increase. We're seeing it go from 200 to now they're talking about 400 or 500 mile range. We're seeing the battery packs that were massive, 3,000-4,000 pounds. They're slowly shrinking those down. I watched a documentary about the first cell phone, that was 13 inches long and 6 by 6, and now we can hold them in the palm of our hands. So, and that's just in 30 years, 40 years. So the speed at which the industry is moving along, I think we're going to get there. I just don't think it's going to be in 5 years. I think it's going to be maybe 10 years, maybe 15, but I don't think it's going to be as fast as what we keep hearing.
Yeah, I think you're right. It's going to be more of it's definitely a disruption and a transformation, but I think in that case it's a smaller transformation than what many people right now are saying. I'm not sure they believe it, but many people are saying, it's going to happen immediately, and I agree with you, right? What's the first thing I did when we lost power? I went out and started my gasoline generator to get the house powered so I can have heat, right?
Yeah, exactly.
So anyhow.
And part of that is just a shift, I think, even in our own approach to things and our mentality, because we've just relied upon, I see for so long we've relied upon our day-to-day things. We take electricity for granted, really. And I think we just have to really reevaluate how we're approaching that as from a personal standpoint too. So.
Yeah, it is. I remember the power went out. I just came back from travel, and it was an hour here, and then power went out, and you walk around, and everything is done. I couldn't get my emails. Everything was down. And if that's the first thing I told my wife is once again, we're reminded how much we rely on one single thing, which is electricity coming into our house, right?
So let me ask you a question, Stephan, and we don't even have to put this on the podcast either. I'm just curious as to what you think. So there's been a lot of information in the news about balloons and other things going over the U.S. Sci-fi. I'm a big sci-fi nut. So you read about EMPs and things like that can totally disrupt your electrification grid or your electric grid. Do you think that that's a real possibility to have something like that happen? And if so, how do we overcome that? Right?
I would immediately say absolutely. I've read enough. I like military stories. I like military technology, not as it relates to destroying people's lives, but just the technology, which is a different twist on what they do with technology, right?
Yes.
Even how do we get to the moon? How do we make planes faster? How do we make accuracies of things that we're shooting? Again, not to kill, but just the technology behind it to do this. And I think EMP, to me, has always been something very fascinating. I don't really understand all the details, but looking at it and reading, there is no doubt that would be a very easy way, quote unquote easy, to disrupt. And I think specifically in the U.S. with an infrastructure that I believe is way different than what you see in Europe, for example.
Right.
I think, again, my story, right? I mean, the house, everything goes dark, and you realize again, there is nothing you can do, and how fast an entire country can be hampered significantly just because we're turning the power off or something turns the power off. It's quite frankly is scary, right? Because again, then you have social unrest. A lot of things happen very, very quickly. And again, how do we communicate today? There is no more landline, right? You use your smartphone.
I still have one for that reason.
You still have one. There you go. So you're safe. You know what? All right, CBs, right? How many people still use that as a communication? The answer is less and less. And then everything else. How do we order groceries today? Well, we go online and we order it there.
Exactly.
To your point, how do we go to the grocery store? Well, maybe we have an autonomous vehicle, an electric vehicle bringing us stuff. Well, that now lost its power, so I'm not getting food. The store loses all its food because the freezers don't work. My EV, I can't use it to go to the store because I need it for potentially having to go to the hospital. Right? I mean, you can go on and on and on, but it clearly your point about infrastructure is I think we're addressing right now the tip of the iceberg. Mm-hmm. I think the reliability, I think sooner than later will come because now we're depending even more on one type of power, right? Or one type of energy solution, not anymore diesel, gasoline. And again, maybe fuel cell comes in, so maybe hydrogen comes in, maybe natural gas will stay around. But generally speaking, that question about infrastructure, I think, is a whole lot bigger, not only from a security that your question was, but also from an availability, right? Than what we're currently, I believe, are faced with or are talking about.
Mm-hmm. Yep, I would agree with that.
Good. Thank you, Brian, for joining.
Stephan, thank you so much for having me on. Appreciate it.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.